that?
Ever since I was a baby, firearms have played a significant role in my life. I got my first .22 cricket for Christmas when I was 5 years old, and I've been going deer hunting with my dad for as long as I can remember. Now that I'm older, I love deer hunting, duck hunting, dove hunting, and squirrel hunting. Whether it be hunting these animals, playing, just plinking around in the field, or target practicing, it's important to know how the action of your firearm works, what features it has, like a safety, and most importantly, where the bullet will go if it is fired. Many factors go into calculating this bullet trajectory. When the bullet leaves the barrel, it immediately becomes a projectile. Only gravity, drag, and wind are acting on it after this happens. Because the scope or the iron sights on a gun are above the barrel, the gun is sighted or zeroed at a certain distance. As shown here, the scope actually aims below where the barrel aims, so that when the gun is fired, the bullet goes and rises above the scope and then goes back from gravity when it's pushed down and hopefully hits the target exactly where it's sighted in for. And then as like the longer distance you sight a gun in for, the more you have to account for gravity, because the bullet is in the air for longer and the drag slows it down more and gravity pushes it down more. So this is a 10-22, and being fired from it is a 22 long rifle bullet. I'm going to shoot it at a close range, medium range, and far range, and see how much the bullet drops off for each ones. If my calculations are correct, then at this distance, shooting at that target right there, the bullet should actually shoot too low, and then in between here and where it's sighted in for, it should shoot too high, because that's gonna be, if I was shooting at something right here, and then where it's sighted in for, it's actually it should hit right where it is. So here goes the first shot from close distance. All right, let's see where it hit. Cut. All right, now I'm gonna be shooting at medium distance. This one should hit a little bit high. All right, now this is the furthest distance. This should be about where the gun's sighted in for, and I'm hoping to be very accurate with this shot. Let's go see where it hit. When considering the force of a firearm, what do you think about? Do you think about the speed of the bullet or the direction of the destruction of the object that's down the barrel? Although these may be the only forces to come to mind, there is another one that is not a force acting on the thing being shot at, but the shooter himself. Additionally, this force is equal to that of the bullet. Newton's third law tells us that for every action, there is an equal and opposite reaction. The opposite reaction to the bullet being fired is a backwards force on the gun and the shooter called recoil. We can find the force of this recoil doing a few simple calculations. The exit velocity, that 1 ounce of lead that comes out of this TriStar 12-gauge shotgun, is about 480 meters per second. I weigh 155 pounds and the gun weighs 5 pounds, so the weight of the system of me and the gun is 160 pounds. The weight of the lead that comes out of the barrel is 1 ounce, so the gun and I weigh about 2,560 times what the pellets weigh. This means that I should be pushed backwards at about 0.2 meters per second the moment the bullet is fired. So we're going to test this and see how close it is. I should probably put hearing on, but you know. Alright, so although it's impossible to tell exactly how fast I move backwards, 0.2 meters per second seems pretty accurate. In the world of shotguns and self-defense, people commonly talk about stopping power. If the definition of stopping power is the ability to stop a person running towards you by the force of the bullet actually hitting them rather than them dying on impact, then we see from this that stopping power is somewhat of a myth. Someone would have to be running at just 0.2 meters per second to be stopped if they weighed a similar weight to me, which, 0.2 meters per second seems like a pretty slow speed if someone's running at you with a knife. So stopping power is a myth and recoil is real. Cut. Okay, so our results show that what I predicted was pretty accurate. The first shot is above the target, the second one was below, and the third one, where the gun was sighted in for, was just about right on. And this is good to know because when doing things like squirrel hunting or, whatever you're doing with the 22, not deer hunting, but I don't know, if you're just shooting, then it's good to know where your gun's gonna shoot because, you might have a squirrel come at you that you think it's gonna be 70 yards away, but he ends up being 10 yards in front of you, and you have to know how to adjust for that or else you're gonna miss. So pretty interesting to see how that works.
Lastly, I'd like to talk about ballistic coefficients. Ballistic coefficients are the measure of an object's ability to overcome air resistance mid-flight. Typically, the higher the number of the ballistic coefficient, the lower the drag of the projectile, and the better the bullet will cut through the air. So it's interesting because obviously guns like a 9mm can have very low ballistic coefficients because of the way that they're shaped. They're fat and not much gunpowder compared to the weight of the bullet, while guns like an AR-15 that shoot 223 or 5.56 travel much faster because the shape of the bullet is much more aerodynamic, and they have more powder compared to the size of the bullet. But it's also interesting how the exact same bullet can vary significantly depending on which gun it's fired out of. This is a standard 22 long rifle Winchester bullet, and fired out of, these are the first two guns I ever owned, fired out of this 22 Cricket, it should go about 12,000 feet per second, while when fired out of this revolver, it only goes about 1,000 feet per second. And this might not seem like a significant distance or a significant difference, but it really is when talking about the force of the bullet and how much drop off it does. So pretty interesting, and I enjoyed doing this project a lot, researching about guns and how they worked, and it's really insightful for a lot of things. Whenever you're shooting or hunting or whatever, it's good to know how your guns work and how the bullets fly.